Today's problem is to validate a given IP address. That is, you will be given an IP address and you have to say whether it belongs to the Ipv4 version of IP address, Ipv6 version of the IP address, or it does not belong to any of these categories. That means it is invalid. So you have to return one of these three values. Now let's see the definition of Ipv4 and Ipv6 IP addresses, and which of them are valid and which of them are invalid. So here I have written the v4 version of IP address and v6. So these two, the first ones are valid. So here you see that we have four components. We have first component A, B, C and D, and they are separated with a dot. And here again you see that there are different tokens. Here we will have 8 tokens, here we have 4 tokens. Here the tokenizer is dot character. Here they are delimited using this colon. So that is the one difference you can note straight away. Not all of them are valid, and we will come to that. And these are delimited by dot characters, and how many of them are? There are 4 components, so we need 3 of them. Here we have 8 components, so we need 7 of them. So this is one difference. Now we should not have dot in the end. So there should be at least one character between the dots, or as the components A, B, C, D. None of them should be empty. Here the same thing. Here we will have more A, B, C, D, E, F, G, H. So none of them should be empty. And in Ipv4 and Ipv6 there are some other differences apart from delimiter. Here the values are between. Each of these values are only numbers. Here you see some alphabets as well as numbers. In general they are hexadecimal values, so not all the alphabets will be present. So it will not be from A to Z, but it will be from A to F. These are the hexadecimal characters, and these are decimal characters. Decimal characters are from 0 to 9. In total 10 characters, because these are base 10 representation. So 0 to 9, that is modulo 10. Any value you take modulo 10, it will be between 0 and 9. Here you will take modulo 16, and modulo 16 values are between 0 and 15. So for 0 to 9 we don't do anything, but we don't allow double digits. So for 10 we keep A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. We will not have 16. These are the 16 values, and this A can be small a or capital A, similarly B. So these things are allowed. So the range is A to F, and 0 to 9. So each character should be one of these 6 plus 6, 12 plus 10, 22 values. No other character. So you will see that it follows all of those. Then let's go into the more detail. So let's dive into the one of these components. So we have looked from high level. Now let's go into the individual components. Individual components will all lie between 0 and 255, both inclusive. So it cannot be more than 255. So if it's 256 or 500 or something like that, any component, then it becomes invalid. And here we will not allow leading zeros. So this 0, 1 is not same as 1. It should be written like this only. So the number of digits can be 3, since it's from 0 to 255 maximum. It can be also 1 digit, 2 digit and 3 digits, but not all 3 digits. Its value should be less than 256. So this is invalid here. You see a 256, which is more than 255. Similarly, this is invalid since D is missing here, the last part. So this is also invalid. This is also invalid due to this leading 0. Now let's look at the Ipv6 rules. So here we have 4 digits each. Each of them are 4 digits, all the 8 components. But if there are leading zeros, you can remove them. For example, this is also valid. This is 1 digit, this is 4 digit. Both are valid, but here you are not allowed to have leading zeros. And you can see some small a, capital A, both are valid. So this is valid, this is valid, this is also valid, and this is also valid. We have replaced both the zeros by single zeros, but we have not removed this leading zero. But you will not consider this as a series of zeros. There is a delimiter between. So you cannot write 2 consecutive colons and write just 1 zero, since all of them were zeros. So this is not allowed. All the components individually should be non-empty. A, B, C, D, E, F, G, H. So that will become invalid if we write like that. So the job is here very simple. Only thing is that you need to take care of the different rules. So what we will do, let's define the rules for these. So here for Ipv4, we have to see that first we split it into tokens. So for each token T, what we will do, we will check if its length is 0 or more than 3. So its length cannot be more than 3, since more than 3 would mean either some leading zeros are there or its value is more than 999. So both are not allowed. We will come to leading zeros in a minute. So if length of T is equal to 0 or length of T is more than 3, then we return neither. Let's write N here for neither. In actual code we will write neither. Then the second condition is that if first element of this token, this is, we are talking about for each token. So this is a T, first token, second token, third token, fourth token. This entire thing is IP. So we are talking at token level. If T0, that is first character, is 0, then again we return neither. So leading zeros are not allowed. Now we have to check the validity of each character. So for C in this token, for all characters in this token, what we will do, if not is digit, so if C is not digit, that means it's not from 0 to 9, that is some alphanumeric characters are there, then we again return neither. And if integral value of this token, that is it's valid, everything is digit, there are no leading zeros, and its length is also within this range. Now we will check whether its value is between 0 to 255 or not. So if this is more than 255, again we return neither. So this we check for each of the tokens, and finally we will return Ipv4, that is it is a valid Ipv4 address. Similarly, let's write the cases for Ipv6. Again we will split it into tokens. So these are the tokens T. So for each T, we will check if length of T is equal to 0 or more than 4, we return neither. So here the length can be maximum 4, it cannot be 0, that is empty, it cannot be empty. And what else? For each character in this token, if C is not hexadecimal or hex digit, then return neither. And hex digits are from 0 to 9, capital A to capital F, small a to small f. So if it's not among these characters, these are not hexadecimal characters, so we return neither. and finally after this loop we return valid Ipv6. Now we have created rules for v4 and v6. Now when should we apply which one? So it's simple. Whatever IP is given to you, IP is the input that is given to you, and it's a string. So what we will do, we will check if IP contains 3 dots. So this is the first path. Let me write here. We have IP here. This is a string. And what we will do, we will check if it contains 3 dot characters, or it contains 7, this colon character, or this is the other case, any other case. Then we return neither here. We don't need to expand this branch further, and we will expand these branches, any one of them, not both. So if it's this case, then check the validity of Ipv4. If it's this branch, then check the validity of Ipv6, which we have already defined the rules. So only one of them will be checked. If it's not among these, return neither. So no need to go further. Now let's write the code for this. Once you list down all the possibilities, writing the code part should be trivial, provided you know how to split strings in different languages. So let's write it in all the 3 languages, C++, Java and Python. So first we will check which one should be checked, which branch we should go to, Ipv4, v6 or neither. So if count is a function available in algorithms, so you have to provide 2 iterators, ip.begin to ip.end, and then which character you want to search. So if this count is equal to 3, then here we will write the Ipv4 logic. So we will fill this. First let's write the high level code. Else if the same thing, so here we will write the logic to check Ipv6 characters, and if it does not go into any of these, then we return neither. So in this question, either you have to return Ipv6, Ipv4 or neither, and the return type is string. Now we will fill these based on our logic what we have discussed. So we need to split it into tokens. So we will use string stream here in C++. It does not have a ready-made split function like Java or Python. So let me add one check for that last character, last component being empty, that is it's a dot b dot c dot d. So if d is missing, this string stream will not be able to catch that. So let's write a explicit case for that. This will not be the case with split functions in Java and Python. So this check will be only for C++. So if ip dot size -1, that is last character, is dot, then return neither, and we will proceed now. So we will keep looking for this token, and it will be kept in this token variable. So if token dot length is equal to 0, that is it's empty, or token dot length is more than 3, then return neither. So this is for leading zeros. So leading zero is only acceptable when we have just one character there. So not all leading zeros are invalid. Let's say we are talking about IPv4. So let's say here we have 100, then we have a 0, then we have 5. So here the first character of this token is 0, but it's not invalid. It's valid since its length is 1. So if it's 0, better its length be 1, otherwise it will be invalid. Now what next? Next we have to check if all the characters are digits or not. So for cin, so we already have a function isDigit in C++. We also have functions like isAlpha or isXDigit. So character check also we have done. Now we need to check if the value is more than 255 or it's less than or equal to 255. So if s2i, string to integer, token is more than 255, return neither. And if none of these scenarios occur, we return IPv4. So we are done with IPv4. Now we will write the logic for IPv6. Here the length should be not be greater than 4. Then we will check if these are hexadecimal characters or not. So here the difference is XDigit, and here it's simply isDigit between 0 and 9. This is between 0 and 9, A to F. And finally, so here also we will need this last thing should not be colon, and I think we are done here. Let's try. So let's check why our answer is wrong. So it's an IPv4, so it should come here. This is valid. This seems fine. If token is 0, so this should be equal to, not, we have not to assign it, but comparison. Let's try again if it fixes. And this gives correct result. Let's submit. And this solution is accepted. Now let's look at the time complexity. It's around 4 milliseconds. Let's try once more. I have seen quite a bit of fluctuation in timing within different submissions. Again, it's in the same range. So let's leave it for now. We will move to Java solution. So let's copy it. This will be mainly for logic. There will be too much syntax change in the case of Java. So let me write it separately only. So here we will apply a filter. Here we will add the Ipv4 check if the count of this character is 3. Similarly, we will add the check for Ipv6 just like here, and then finally we will return neither. And now let's convert it to Java. So what we have to do, we have to split this IP into tokens. So the way to do that here is much simpler. Simply write ip.split and it will split it into tokens, and we will iterate for each token, which is this loop. And we are done. Now this length is valid, and so here each digit is not valid, it's capital D, and here also you need to change integer dot parseInt token is more than 255, return 0, return neither. And now let's write the logic for Ipv6. So this function is not there in Java. So what we will do, we will write our own function. So if not C is greater than equal to 0, if it's greater than equal to 0, we will check it should be less than equal to 9, or if it's not in this range, then it should be between A to F or capital A to F. Or So we got a couple of errors here. This looks like a typo, and this each digit is not found since it's inside character. And this is also wrong. We should have changed this to this. And the solution in Java is accepted. Finally, we will do it in Python 3. So if this count is equal to 3, then write the logic for Ipv4. For each token, we will check if length of token equal to 0 or len token so this line is also done. So here in Python we don't need to check for each digit, we can check the token itself. So what we will do, if not token dot is digit, so this we can directly check. So we have combined both the checks into one. We return neither. So here we will check if each character is between 0 and 9 or not. 0 and 9 and A to F. So again we got a wrong answer for IPv4. This not is not required. We have already done not equal to. And this Python solution is also accepted.